Okay. Hello and welcome to Module 4, Lesson 8 of 8th grade math here. In today's lesson, we are going to talk about exactly what the title explains, and that's linear equations in disguise. So we have been solving equations for x or y or whatever variable, and I showed you an alternative way to do that by making a chart. And I'm going to show you that not all linear equations look like linear equations to begin with. So starting on page 25, we have our first example. It says example 3 on yours. And you have a fraction on the left with algebraic terms in it, and then you have 3/8 as a fraction on the right of the equation, and then you have a fraction inside the fraction of 2/3. And at first glance, this looks mighty intimidating, but actually, this is a linear equation, and here's why. Let me throw you back to 6th grade when you were learning fractions, and you learned that if you have a proportion like this, that you could multiply, cross multiply, the numerator with the opposite denominator on both, and then you can have them still be equivalent. Well, that's what we're going to do here. So we're going to rewrite this equation by cross multiplying. We're going to start by cross multiplying the 6 plus x and the 8. Now, something that will help us out is by taking whatever that singular number is and writing it first. And then we're going to write the equation part in a parenthesis like this. And then we're going to say that is equal to then the other side, which would be to cross multiply the 3, that's our singular number, with 7x plus 2/3. And this now looks like a linear equation that we've been working with. And in order to solve that, the first thing we need to do is distribute. So now we're going to do 8 times 6 first to get 48. And remember, this is like 1x here, so 8 times 1x is going to be positive 8x equals 3 times 7x is 21x. And then 3 times 2/3, you can either do that out the long way. Remember, on your calculator, you can type 2/3 in by doing 2 divided by 3 and then timesing it by 3. And you'll find out that that's just 2, so plus 2. And now you have no parentheses, and you have this linear equation that you can either solve the traditional way, or you can use the alternative way that I showed you by making a line down the equal sign and putting the x's on the left and the numbers on the right. 48 then is a number. We cross the line, so it's negative 48. 8x is an x, and it stays there, so it stays positive. 21x goes on the x side. It crosses the line, so it's now negative 21x. And 2 is a number. It's going to stay put and stay positive. Now remember, from here, we add, so 8x plus negative 21x is going to be negative 13x over here. And negative 48 plus 2 is negative 46. And now we are going to divide because we want to undo the multiplication here. So divide by negative 13 to cancel it out, and divide by negative 13 to get the answer. Now, don't forget, when you type that in your calculator, these are both negatives. So negative 46 divided by negative 13, and you get, and we're going to have to round here, a big long decimal. We're going to round it to 3.5. X equals 3.5. Okay, so that seemed like a lot of steps there, but the point is, these crazy fractions, these crazy proportions, algebraic proportions, you can solve using linear equations. So let's try another one, just so that we can hammer the point home here. I'm going to start And it doesn't matter which way you start. So there's another point that I forgot to mention. I'm going to start by cross multiplying these two terms. So I'm going to start with a singular number of 1, and then in parentheses I'm going to put 3x plus 9. That's what I'm going to start with on the left. And on the right now I'm going to cross multiply this side. I could have started the other way around though. Now on this side I have two singular numbers, a 7 and an 8. Because that's the case, it doesn't matter which one you start with. I'm going to start with 7, and then in parentheses I'm going to put my 8. I could have done the 8 on the outside and the 7 on the inside. It would give me the same answer. Now I'm going to distribute. 1 times 3x is 3x, plus 1 times 9 is 9. And now I only distribute once. 7 times 8 is going to be 56. And guess what? You can either solve this the traditional way, or you can solve using a chart. Since we've been using charts, I'm going to do the chart way. X's are on the left, numbers are on the right. So 3x gets to stay here. The 9 crosses the line, so it's negative. 56 stays on its own side, so it stays positive. Add them up. 3x doesn't have anything to add to, so it's still 3x. Negative 9 plus 56 is going to be 47. And the last step here, we want to undo 3 times x. To undo that times, we're going to divide by 3 here and divide by 3 here. So we will do 47 divided by 3. And our final answer here is x equals 15.6 repeating. Those of you that are familiar with fractions know that is also 15 2/3. And again, another way to solve this using linear equations. Now, I want to hit one more example for the sake of the video to make sure that we're all on the same page, and that example is example 5 on page 26. This is a different kind, another linear equation in disguise. So you look at this and you think back to what we did earlier in the year, and we did similar triangles. So it says ABC, this guy, is similar to triangle A prime, B prime, C prime. And if you think back to similar triangles, the first thing I think of is scale factor. And that's what we're going to use here. So it says use what we know about similar triangles, we can determine the value of x. If you recall, to find scale factor, we divided. We found a larger side, and we found a match of a smaller side, and we divided them to find scale factor. So I'll do that here. X minus 2 matches with, so AB matches with A prime, B prime, so in this case 9.5. If I were to divide those, I would get the scale factor, which means that I should get the same scale factor or an equal scale factor if I do AC, x plus 2, and divided that by A prime, C prime, 12. And now we have that proportional relationship that we had on the first page, and we can cross multiply to make a linear equation. So I'm going to start this time by doing 9.5 times x plus 2. And then I'm going to do on the other side of the equation 12 times x minus 2. And I'm going to solve this as I solved all of the previous ones. I'm going to do distribute 9.5 times x to get 9.5x, plus 9.5 times 2 is going to be 19. And then I have to distribute this side as well. 12 times x is 12x. And then 12 times negative 2 now is negative 24. And then you no longer have parentheses, and you have this linear equation, so you can solve it traditionally or you can solve it using the chart. I'm going to solve it using the chart. X is on the left, numbers on the right, so 9.5x gets to stay. 19 has to go over here and is now negative 19. 12x has to jump the line to get to its home, so it's negative 12x over here, and negative 24 stays here, so it stays negative. Then we add these guys up. 9.5 plus negative 12 is going to be negative 2.5x over on the left, equals, if you add negative 19 and negative 24, you're going to get negative 53. And then the last step is going to be to undo this multiply here on the left side. So to undo the multiply, we're going to divide by negative 2.5 here. We'll divide by negative 2.5 here. And we get, so negative 53 divided by negative 2.5, you get x equals 21.2. And there you go. Oh, that should have been 43. Oh my goodness, I made a mistake. That should have been negative 43. I'm sorry. So negative 43 divided by negative 2.5 gives you 17.2. My apologies. X equals 17.2. Just seeing if you're paying attention here. All right. And that's how you get your final answer. Again, another linear equation in disguise. Okay, that's all the examples we're going to do for the video today. The assignment is going to be the next page here, page 28, numbers 1 through 10. And you got to show your work. Remember, no work, no credits. If you have questions, please come in and see me either before school or at lunch, and I'll be glad to help you out.